The next problem which we have is a very interesting and a very important problem. We are required to find the sum S, which is given by NC1 sin alpha cos of n minus 1 alpha plus NC2 sin 2 alpha cos of n minus 2 alpha going up till NCn sin alpha. We are required to find the sum using binomial approach. Now what we do is, we write the sum S dash is equal to NC1 sin alpha cos of n minus 1 alpha plus NC2 sin alpha sin 2 alpha cos of n minus 2 alpha going up till NCn minus 1 sin of n minus 1 alpha cos alpha. Now what we do is, we write this whole expression in the reversed form, that is S dash is equal to NCn minus 1 sin of n minus 1 alpha into cos alpha. What we are doing is, we are looking at the terms in the reversed order. Here we have NCn minus 1 sin n minus 1 alpha cos alpha, and we are writing this whole expression in the reverse format. So we get S dash is equal to NCn minus 1 sin n minus 1 alpha cos alpha plus NCn minus 2 sin n minus 2 alpha cos 2 alpha, and writing the last term as, which was the first term in the previous S dash, as NC1 sin alpha cos of n minus 1 alpha. We have not done anything special, we have written just the whole expression in the reverse format. Now we know that NCr is equal to NCn minus r. So we can write this NCn minus 1 as NC1, this NCn minus 2 as NC2, and this NC1 as NCn minus 1. Now we add both the two expressions vertically, one term with the other, to get 2S dash is equal to NC1 times sin alpha into cos n minus 1 alpha plus sin n minus alpha into cos alpha. This is sin A cos B plus cos A sin B, which is sin of A plus B. So we get sin of n alpha. Similarly, again we add vertically downwards to get NC2 times sin 2 alpha into cos of n minus 2 alpha plus sin of n minus 2 alpha into cos 2 alpha, which is again the formula of sin A cos B plus cos A sin B, which is sin of A plus B. So again the sin of A plus B becomes sin of n alpha. Going in the similar fashion, we can very clearly and obviously say the last term will be equal to NCn minus 1 sin n alpha. Now what we do is, we take out sin n alpha common and write it as sin n alpha into NC1 plus NC2 plus NC3 up till NCn minus 1. Now adding and subtracting NC0 and NCn in the right hand side of this expression, we know that NC0 is 1 and NCn is also equal to 1. So we add an NC0 and subtract a 1, and similarly add an NCn and subtract a 1. Now clubbing this NC0 and NCn with this expression of NC1 plus NC2 up till NCn, we get 2S dash is equal to sin n alpha into NC0 plus NC1 plus NC2 up till NCn minus 2. We did this because there were two terms missing in the given expression. They were NC0 and NCn. So we added and subtracted the two given terms. Now we know the sum of this expression. You should always remember the sum NC0 plus NC1 plus NC2 up to NCn is equal to 2 power n, which we can very easily prove. 2s dash is equal to sin n alpha into 2 power n minus 2. So we get s dash is equal to sin n alpha into 2 power n minus 1 minus 1. So we rewrite the whole expression again. We get s dash is equal to sin n alpha into 2 power n minus 1 minus 1. And we needed to find the sum of s is equal to s dash, and we left the last term which was written to be NCn sin n alpha. Now sum will be equal to sin n alpha 2 power n minus 1 minus 1 plus NCn, which is equal to 1 sin n alpha. Now this minus sin n alpha gets cancelled out with this plus sin n alpha, and what we are left out with is 2 power n minus 1 into sin n alpha, which is the required answer.